The intro is basically why program in TypeScript. What is TypeScript? TypeScript is a language which is compiled into JavaScript. So basically the process goes like this. You write something in TypeScript, you start the compiler, and compile, and you get the JavaScript piece, the equivalent JavaScript. This JavaScript can be used anywhere where JavaScript can be used. So it can be used in HTML pages, it could be used on the server side, it could be run separately as a program, and you can see the output on the console. So the question is that you may ask, or you may have, why bother? Why should I even bother writing something in language A and then compile it to language B, in this case JavaScript, if I can just write code in JavaScript without all these troubles? So what is the benefit? Why would I do something like this? In my opinion, when I say in my opinion, it's an opinion of a person who spent many, many years working with different programming languages, and most of my programming experience is in Java. Java server-side mainly. I know the language, I know how it works, I know how compiled languages work, and being a Java developer for the most of my life in programming, I can tell you that Java developers look kind of down on people who work in JavaScript. They think to themselves, Java is a real language, but JavaScript is a toy. It's unpredictable, it may or may not work, people make fun of JavaScript. It doesn't tell you if you make an error. If you type something and you make a mistake, what kind of mistake? JavaScript is a dynamic language. So if, for example, you declared a variable of type string, but you assign a string to it, and somewhere else you assigned a number to this same variable. So the type of this variable automatically is changed to a number. In JavaScript, you don't even have a chance to declare a type of a variable. You don't need to declare a type. So all these little things may cause problems when the program is deployed in production. You write a function that has 5 arguments. What are they? What are these arguments? Are they all numbers, or maybe some of them are strings? How are you supposed to know? Oh, you are a smart programmer and you can read the body of the function and you will figure it out. What if somebody else will be reading your code? What if you made a mistake and assigned the value of the wrong type? What if you have a function that's supposed to get an object of type user, and somebody who sends you the data, for example, the data comes from the server side as a JSON. Somebody on the server side added a couple of fields and they forgot to tell you about it. You are a front-end developer, right? So the structure of the object is different. Your code may crash during the runtime. Then you'll figure it out and you will fix it. But wouldn't it be nice if you could fix the problem sooner, before deploying the code in production? Let me show you a quick little sample. And what I'm using now, I'm using so-called Playground, TypeScript Playground. There is a site called TypeScriptLang.org. And if you go there, you will see this menu, Playground. In there, you will see the screen split in 2 parts. On the left, you can type something. You can type the code in TypeScript. And on the right, you will see the equivalent in JavaScript, the compiled version. Let me get rid of this piece. And let me start typing something. For example, let x equal 3, for example, something like this. I wrote this line in TypeScript. And on the right-hand side, you see its equivalent in JavaScript. And you can tell me, these lines are, these both versions are the same, right? It's right because I didn't use types on the left. Let me do this. Let me declare that the variable x has a type number. Take a look at this, by the way, a number. See, I'm making mistakes, I'm getting help, autocomplete, and IntelliSense, right? So I will not make a mistake. So look at this. On the left-hand side, I declared a variable x of type number, and I assigned 3 to it. On the right-hand side, you see a transpiled version. By the way, the word transpile, it's like compiled, but a compiler would compile the source code in any language into a machine code or maybe into a byte code. But when you say the word transpile, we mean that the code will be compiled from one source language, from the source in one language to the source in the other language. As you can see on the right-hand side, you see the JavaScript version of the code, but without the type, without the number. All right, so to transpile means to convert the code from the source in language A to the source in language B. So if this would be a real project, we would be deploying this piece of code. So browsers or any other JavaScript language, they still need JavaScript. They don't run TypeScript. So there is a process, there is a step to compile. Now let me show you another example. Let me do this. Take a look at this function on the left. Ignore what's happening on the right. And as a matter of fact, it is JavaScript on the left now. What I will do now, you see a couple of lines of a couple of variables, actually arguments of the function, point A and point B. They are underlined with this squiggly red line. This is basically TypeScript compiler complaint. Remember, on the left we see the TypeScript compiler. It complains saying that since you didn't declare the type of this parameter, it assumes that the type is any. Any is a bad practice and you shouldn't be doing this. They say that. So what I will do, there is a config. I can configure the TypeScript compiler. See, this is a checkpoint. It says no implicit any. Don't do this. Don't assume that the variable has a type any. Let me uncheck this. Let it see. Now it'll allow me to have implicit any type. Anyway, so the good part about TypeScript that it has optional typings. Types are optional. It's not like in Java. If you won't declare the type of a variable, it won't work. It will, and that's the beauty of it. So if you have a JavaScript project with a code base already written, and you want to go in the TypeScript direction, and you want to move to TypeScript, you don't have to declare a type for each and every variable. No, you don't need to do this. See, as you can see, it doesn't complain because TypeScript is a superset of JavaScript. Valid JavaScript code is considered to be a valid TypeScript code. And you can see it over there. So what's the problem in this example? Anybody can look at it, take a look. It's basically Pythagorean theorem, if you remember. A power of 2 plus B power of 2 is equal to C power of 2. It could be used in particular to calculate in geometry. So let's not go there, but take a look at this code on the left, guys. Do you see any issues in there? Somebody is saying you need the type of the parameters. It's optional. Yes, I need it, and I will show you how I will add it now, but it's optional in TypeScript. It's complained, but it can run. Yes, basically in TypeScript there is an option that is, I don't know if they have it over here, but if you would be using IDE, one of the IDEs, I'm using this playground thing because for me it's easier to show you something. But if you'd be using regular IDE, there or you also can specify the parameters of the compiler, and one of them is no emit on error. If you would say that if you want to go all the way down and say I'm using TypeScript, I will declare the type for each and every variable, then it'll produce the code anyway. If you don't want this to happen, you can say no, don't emit the code if there are any errors. In that case, the code wouldn't be generated. But in this particular case, from the JavaScript perspective, this code is valid. There's no errors, right? Anybody see a problem? Yes. There's a guy called Gray Programmer, and he says the Z member of an instance, line number 7, very good. congratulations that you are experienced person and you notice that thing, that little thing. Look at this. I wrote a function called distance. It's assumed to take, it assumes that I'm going to provide two objects, right? There is a point A and there is point B, and I want to calculate the distance between the two, right? And I'm using, see this, I'm taking a square root from a minus x coordinate of a minus x coordinate of b in power of 2 plus x y coordinate of point A minus b power of 2. Yeah, I'm supposed to give the object that represents point A and an object that represents point B. In JavaScript, in this case, I'm using object literal notation, right? So what did I do? I made a mistake. I assumed that this point has the property z, which it doesn't. So the whole thing wouldn't work in JavaScript. JavaScript wouldn't catch this error, and I could deploy this super important code, and I could deploy it in production, and boom, it blows up. Right? Because I'm using JavaScript, there is no type checking. They assume that I'm good enough, like in this case, great programmer. Or this little thing you're right in saying that it may take a long time to find this little thing. And it's just a 7-line piece of code. Think of a large project. All of a sudden it blows here, it blows there. So what would I do with this little code on the left to introduce type, to show you the advantage that TypeScript brings to the table right away? So what I would say, you know what? I need to define a type that represents a point. I need to calculate the distance between point A and point B, or maybe something else. So how can I do this? There are different ways of doing this. Let me do this. I will declare a class. I will call it point, right? And in there, I'll declare two properties. One of them is x of type number. See, I'm writing TypeScript now, and what did I do wrong? I don't get it. Let me see. And the other options. See, compiler. In TypeScript, there is a thing called TypeScript language service. It's like a big brother. It is sitting there and watching what I'm doing. In this particular case, it says property X has no initializer and it's not definitely assigned in the constructor. All right, so it's another option. It wanted me to declare a property and assign it to initialize it with 0 or something. But again, it's an option of the compiler. I'll shut it down. Where is that? Strict property initialization. I will uncheck this option so it wouldn't complain about that. All that is configured, of course, on the compiler. And the variable y of type number, right? So I declared a new type. I declared a new type, class point, which has two members, and both of them are numbers in this case. So far, so good. But I didn't use it anywhere in the function distance, and I will now. Look at this. I will start declaring that point A is of type point. But meanwhile, keep an eye on this line over here. As I type, it'll notice that z is wrong. Z is not existing property of the point type. Column of type point. See, it helps me. It tells me what can I put in there. Look at this. I didn't even finish typing. Look at the line number 9. Oh, 12, sorry. Look at this. It says what? Argument of type, curly braces, object literal, z number, y number is not assignable to parameter of type point. Of course, it's not a point because it has no z. Of course, I will do the second argument of the type point as well. See, I am still typing. I didn't deploy anything. And it already tells me that I'm wrong. Isn't it beautiful? It is. Trust me, it is. You can say, I'm a JavaScript developer. I don't want to bother declaring type. I will never make this mistake. You will. You will. We talk about productivity. which increases. You don't need to deploy JavaScript to see this error. Now, since we are looking at this little example, I want to show you something else. So how do you declare types? First of all, there are basic types like number, string, boolean. They already come with the language. But you can define your own type. Like in this case, I was using the keyword class. By the way, JavaScript has classes as well since 5 years ago, since ES6 spec. And look at this, on the right-hand side, the JavaScript code was generated based on my, on the left-hand side, TypeScript code. In this case, in JavaScript, in JavaScript, you can compile your TypeScript down to different specs of JavaScript. ES5, ECMAScript 5, even the oldest, super oldest one, ECMAScript 3, ES 2015, which is also known as ECMAScript 6, ES6. All these, every year they release a new version, right? Let me do this. No, they didn't do it yet, I guess. Basically, what I wanted to show you, right now, there is a proposal to introduce fields in the class in JavaScript, right? So these would be fields. So some browsers already support it, in particular Chrome supports it, but if it will become the final version, final stage of the ECMAScript, fields in the class, and then we would see fields in there. For now, it doesn't exist, so it just said that it should be class point with no properties. In here, it ignores the type because, once again, because JavaScript doesn't have types. Now, what else I could have used in here? I could have used the keyword interface instead of type. Look at this. All of a sudden, on the right-hand side, I don't see anything generated for this point. No footprint at all. So, if you want to declare a type and you are not planning to instantiate objects of this type, I declare a type. In this case, I just only want to use it as a type. I'm not planning to create an instance of a point, right? In this case, I only use the, what do you call it? The object literal. If you just need a type, so to do the type checking as you write the code in development mode, just use interface. Or there is another keyword called type. The good part is that since JavaScript doesn't have this construct type, it will not generate any equivalent code. If this would be a large data type, for example, user, 25 fields, or maybe order, you're placing order, or maybe shipment, 25 fields, 20 fields, 15 fields, it's a good idea to use interfaces. Why? Because it doesn't generate code in the production version. So your code base becomes smaller. So these little things already show you that you can get benefits right away. Even if you will try to run your existing JavaScript code through the TypeScript compiler, you may be surprised. And it'll try to compile your code. It's supposed to be able to generate JavaScript from valid JavaScript. If you had some little bugs that you never even noticed, maybe they showed up in production but nobody noticed, TypeScript compiler will check it out for you and will say this is wrong, and that is wrong. Sometimes you will read in blogs, in books, in articles, that TypeScript is a superset of JavaScript. Meaning what? Meaning that whatever JavaScript understands, the syntax, should be understandable by TypeScript as well. So Ideally, if you will take any file with extension .js for JavaScript and just rename it to .ts, you should get a valid TypeScript program, with some exceptions. For example, in JavaScript, you can dynamically assign fields to the objects. This is not allowed in TypeScript. These cases would generate errors in TypeScript. You may have bugs. For example, you have a function in your existing JavaScript program. You have a function that expects the type string, and you put number in there. Somehow it worked. TypeScript compiler would help you out. Now, what is so special about TypeScript? It's already second year in a row Stack Overflow developers are filling out the survey, and well, different things. What is a popular framework, the popular language, this and that, tools. TypeScript is second year in a row is in the first 3 most loved languages. People want to learn it and use.